Hey everyone, I'm Nitin Ranjan, 18BCE 0272, and as a part of my parallel distributed computing project, a lab assignment, I'll be demonstrating the code for uh, the Monte Carlo problem for determination of the value of pi using OpenMP library, right? So OpenMP is basically a free library. It's freely available on the GCC distribution. So what I used here is Ubuntu 20.04 on Windows subsystem for Linux uh, version 1, right? Let's start with the code right away. So stdio dot so of course we begin the C code with of course including the basic header files. So the header files stdio.h and stdlib.h are all important for any C file because they contain functions like scanf and printf, right? Now, OMP.h we have used because, of course, as I said, we're using the OpenMP library and, the OpenMP library, and OpenMP library is available uh, only after using the OMP.h header file, right? We require some mathematical functions, hence we import the math library, and we also require this time function, hence we import the time library. These are generic codes coming all the way to the parallelization part. So any OpenMP program runs on the idea that there is a master thread, and that master thread is then distributed into a lot of private threads. This is exactly what this line does. Hash pragma OMP parallel first private XYZI shared count num thread. What this does is it creates a number of private threads in the master thread, right? Now, srand int time null. So yeah, as you can see, we have used the time function here. Hence, I imported the time library, right? And the time function needs at least it always needs one argument. And so there is literally no argument to begin the uh, program to begin that particular thread. There is no time argument to begin that particular thread. The input we give is null. All right. uh, what this line srand in time null, and this is the XOR operator, OMP get thread num does is that it creates a seed value. Now what is a seed value? A seed value is any value with which the thread will begin its generation of numbers, right? So yeah, so Monte Carlo problem is based on the idea that if a unit circle is inscribed in a unit square, then the value of pi will be equal to 4 times the area of circle divided by the area of square. So, thinking it in a bit a bit more in the way in which a computer might work, what we think is, let there be a number of points, let there be an indefinite number of points in the square. So the number of points which lie inside that circle, which is inside that square, will be roughly equal to the area of the circle. So on this line of similarity, we say that the 4 times area of circle divided by area of square will be equal to 4 times number of points inside the circle divided by number of points inside the square, right? That is the basic concept of the Monte Carlo problem, right? So what this line does is it creates a seed value, a random seed value. Srand ensures that this value is random. So a random seed value for every thread. Otherwise, what will happen is all the private threads that come from the master thread will have the same seed value. So we will not have a lot of values generated. Every thread will generate the same sequence of numbers. Hence, we use this line. Now, x double rand divided by double rand max. As you can see, rand max will always be greater than this rand. So x will be some random value uh, less than 1 or equal to 1. Similarly, y will be some random value less than or equal to 1. Now, if x and y are some random value less than or equal to 1, they will always lie inside the square, right? What is our concern is to find out if they lie inside the circle as well. Now, if they lie inside the circle, then they will obey the equation x squared plus y squared equals to 1, right? Because the radius of the circle is 1. If they lie inside the circle or on the circle, so they will obey the equation x squared plus y squared less than or equal to 1. So let us say that there is some even more generalized function x squared plus y squared equals z squared, this z value. So we say that z equals to square root of x squared plus y squared, this power function get it from the math.h library. This function, this line of code says that z or z is equal to square root of x squared plus y squared. Now, as I said earlier, if x and y lie inside the circle, then the value of z should be less than or equal to 1. So, if z is less than or equal to 1, count increments. So, what do we understand? Count is the number of points that will lie inside the circle, right? So, the value of pi, as we discussed about the Monte Carlo problem, is 4 times this 4 times count, which is the number of points that lie inside the circle, as we discussed here, divided by num into num thread, right? What was num? Num is the number of iterations that we run. So of course, all the iterations that will run will always generate a point inside the square, right? Into num of threads. So every private thread will generate num number of points inside the square, right? And out of these num into num thread points, count points lie inside the circle, right? So the value of pi will be equal to count over num into num threads, the whole multiplied by 4, right? And we just print the value, right? Now just let us just execute this code, right? Now this execution, so of course, as I said, it's GCC library that I'm using. O Monte Carlo. Now this is the compiled file's name. Then of course F OpenMP, because we are using the OpenMP distribution in GCC. So this is the extension that we put. We are compiling the file monte.c, and since we are using the math.h library, the point is math.h library does not work after Ubuntu 12. As I said, I'm using Ubuntu 20. So after Ubuntu 12, math.h has to be explicitly added in the compilation. So this hyphen lm does this. This hyphen lm will explicitly add the math.h library. All right. Now let's just run this code, Monte Carlo. So let me say that I run it for like 40,000 iterations on 2 threads. So I get the value of pi is 3.102750. So that shows that this is insufficient, right? So let's just run another code, this time for 1 million uh, steps and for 2 threads only. So it becomes 109. It's still closer. One last time. Let me run it for 1 million times. Yeah, and for 4 threads. See, this is very close to the actual value of pi, right? Because 1 million will be the number of loops and 4 threads. So the number of points generated is 4 million. So out when we do, and here the number of points will be 2 million, and here the number of points generated was 80,000, right? So yeah, that was the Monte Carlo problem. Thank you so much.